You probably know what is a log agent. You know fluentd, you know fluentbit, but you heard that there's a new one coming on the market called Stanza. Stanza, you probably know that it's been donated to OpenTelemetry. So if you want to know a bit more about Stanza, what's the value, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of an existing series, the OpenTelemetry. In fact, it's a bit more related to logs, so it's going to be also attached to the logging series. Today's episode will be focused on a logging technology that has been donated to OpenTelemetry, and I'm referring to Stanza. If you enjoy today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We will start with an introduction. Then we will explain how to design a Stanza pipeline. We will look at the various operators available in Stanza and the notion of plugins. Then, like usual, we will jump into tutorials showing you how to deploy it and how to utilize Stanza. Stanza is a log agent collector and forwarder similar to fluentd or fluentbit. Stanza is a solution that has been built over the years by ObserveIQ and had been recently donated to OpenTelemetry. It will soon be embedded in the OpenTelemetry collector. So to understand the potential features that we will have soon in the collector, let's study in detail Stanza. Stanza has been presented as the most lightweight agent log collector and forwarder, and it's been based in a Go language. It's the new kid on the block in the logging space. Stanza could be utilized in various ways. In a traditional bare metal environment, utilizing a Linux, macOS, or Windows deployment, or in Kubernetes. Similar to the other log agent collector of the market, Stanza requires to define a pipeline describing your process to ingest your logs. You will first need to collect, then we will parse, probably filter as well, and then last we will forward the log utilizing an output plugin. Let's have a look on how to design a pipeline. The pipeline will be stored in a configuration file in the case of a bare metal deployment. But in the case of Kubernetes, like usual, we will store our pipeline in a config map. What is interesting with Stanza is the way of designing the pipeline. The pipeline is structured in a sort of a YAML format. Here is an example of a pipeline. You see, there's a type, you precise the operator name, and then you have various arguments related to that specific operator. And every operator has optional parameters like ID and output. Every step of the pipeline corresponds to an operator. In our example, we have two operators defined. It is designed to create either linear pipelines or non-linear pipelines. Linear pipelines means we follow the flow defined in our file. Here we have operation 1, then operation 2, and last operation 3. But it's also possible, but not recommended, to change the order. In that case, we have to use common parameters of each operators, output and ID. Output will define which step will follow the operation. ID will be the name of the current operation. By default, the operation will be named by the type of the operation. One important concept, we always start by an input operation. The first operation will be there to collect the logs from a source, and that will be our starting point from our pipeline. We usually use operation like file input. For example, here we have a pipeline with first, we can see we start with the JSON parser operator. Then we have the second step is the third operator, the std out, the output. And last, we have the first operator, which is the file input. And you can see that the file input precise that the next operator is the JSON parser. We can also precise the ID of the task. For example, here it is, file input. You can see that I can have an idea where the file could be named file input or file first step, and then we have the various parameters of the operator. Similar to the other log agent of the market, Stanza produced a JSON object. And here is the structure. We start with a timestamp that will be the timing of the logs. Then we have a record object that could have several properties. And we usually find a message field that will contain the content of our logs. We have a resource object. We can add as many resource, so key value pairs. And also we have a labels object that will contain all the various labels attached to our logs, so key value pairs. And last, we have a severity, and the severity in Stanza is expressed as a number. Stanza has default expression allowing us to access to one of the objects of the log stream. You can see that here we have various parameters like $timestamps corresponds to the timestamps of the entry, record corresponds to the content, the array that contains all the content of our log streams, the resource that contains the table with a map with all the resources of the log streams, and similar with the labels where we have a map with all the labels, and last we have the severity. We can also use env is an operator that will help us to access to environment variables. You can apply as well various expression operator, like either arithmetic operators, comparisons, we have a logical operator, string operator to match, contains, start with, arrays, in an array, not in. And then there are a couple of built-in functions like len for the length, all that will return true if all the elements satisfies a specific conditions, none if none of the elements satisfies the conditions, any, one. We can filter array by contentions, map, count, and so on and so forth. For example, you can see here all messages severity contains info. So we are looking for all the logs where the severity is info. An operator in Stanza is a task of our log stream pipeline that will help us to read from a file, parse the logs, filter, or push it to another log stream pipeline, similar to the forward plugin that we have introduced with the FluentD or FluentBit episode. Or we can directly push it directly to one of our observability backend of our choice. Similar to the other agents of the market, there are several types of operator. There is the input, the parser, the output, and the transform operator. Stanza has several input operators. File input, obviously the forward input to receive logs from another Stanza agent, Windows event logs, TCP, UDP. We can also collect from journald, and then all the various integration with cloud vendors like AVS CloudWatch, AVS Event, AVS Log Analytics, and then you can also interact with receiving HTTP in streams, and also anything related to Kubernetes, so Kubernetes events input. Each operator has its own set of parameters, except of ID and output that will be common for all the operators of Stanza. You should check the documentation of Stanza. There is always new updates with new operators. Maybe there is one that will help you in your specific project. The Parser plugin. Stanza has various Parsers plugins. Most of the Parser plugin will have common fields. Parse from, that will precise which field will parse the content. We have on error, if, timestamp, and severity. On error, we will precise what to do in case of a parsing issue. Either we drop the log stream or we could continue the pipeline. Timestamp, we will precise that one of the fields that from what we have parsed has some time and we want to use it to attach it to the timestamps of the log stream. Severity will be there to also extract the severity from the message to populate the severity field of Stanza. If is the field very useful that will help us to make a condition on when we would like to apply that specific parser. Let's take an example. Here is a pipeline. You can see that we are parsing a specific field, parse from, and we can extract some timestamps or some severity. The severity has mapping options that will help us to map values from our messages, our content, to a specific severity level. Here is an example of the mapping, and the mapping could help us to either parse a single value, so error equal a specific value, or we can give a list of value to be parsed, so warning, and then we can give a list of value that match the warning level. Or we can also structure a range of values to be parsed, like info, with the minimal value for info and the maximum value for info. The CSV parser. The CSV parser will help us to parse the log stream or specific log fields and to extract some content. You can specify the log key names using the header fields, and you can also customize a delimiter. So here is an example of a CSV parser where we parse from the field message and we specify that we have a specific header, ID, severity, and message. So now if we receive a message that will be structured in the following way with one space debug, debug message, then as a result after the CSV parser, we will get from the CSV parser the ID that will be extracted, the severity that will be also extracted, and then we will still have our message. If you have a log format, a log FMT, then you can imagine to use this CSV parser which with a delimiter that will be set to tab. The JSON parser, it will be there of course to extract JSON content stored with specific fields. You can utilize the if operator to validate that the content is JSON to avoid having parsing issue. So here is an example of the JSON parser. We parse the content of the message field and then we attach to it a timestamp extraction where we specify the format, the layout, and so on and so forth. If you want to check that the message is a JSON structured, then you can use the if arguments. So here is an example, so JSON parser, and if you can see we use expressions, so records, match, and then we make sure that we have some brackets there. Out of the CSV parser and the JSON parser, Stanza also offers the regex parser, naturally, the syslog parser to parse log in a syslog format, the severity parser, the time parser, XML parser, URI parser, and key value parser. Let's have a look at the transform operators. Stanza has operator that will help you to filter and add extra metadata. You can also restructure the log and you can do way more. let's have a look at few useful operators. Rate limit. Rate limit is an operator that will help you to limit the rate of logs that you want to send to your backend. If your backend solution allows a certain number of logs per second to be ingested, then this operator will help you to limit the traffic that you want to push to your observability backend. Filter. Filter, as you probably understand, it will help you to filter the log stream, to limit the log stream respecting specific conditions. So here is an example of a filter operator. So you can see that expression where the log key contains is observable. So at the end, all the logs containing is it observable will be dropped. You can also imagine to filter based on label. So here is an example. We use again the filter operator, and here we can see that the expression is based on the label. So the label namespace equal Istio systems, then it means that we will drop all the logs that comes from the namespace Istio system. Route. Route is very important. The route will allow you to create different routes in your pipeline based on specific conditions. For example, we have here a route where we can create several routes possible. We have one where we will push it to a JSON parser if the format is JSON. We can then push it to syslog parser if the format is syslog. We can push it to a CSV parser if the format is CSV, and so on and so forth. Metadata. Metadata is an operator that will help you to enrich your log stream by adding new labels or resources. By combining expression, you will be able to create dynamic metadata. So here's an example with the type metadata. As you can see that the labels, and here we have environment, and the expression allow us to say if the environment equal production, it will be, the value will be prod, otherwise it will be dev. Restructure. Restructure is an operator that will help us in changing the records of our logs by adding, dropping, moving fields. Restructure will take a list of operations, ops. In terms of operation, it accepts add, move, retain, remove, or flatter. Add and remove is clear. No explanation is required. Retain will specify which field you would like to keep, the rest will be removed. So which means all the other keys that was present in our logs will be dropped. Move. It will basically help us to rename fields. Flatter will move fields having JSON content to the parent level. So if here is an example, we have restructure with flatten key 1. As you can see, the contents of the object key 1 has been moved to the parent level. Host metadata. If you are interested to add metadata related to your hosts, like the IP address, the host name, then you can use this operator to add extra information in your log stream. Kubernetes metadata decorator. This operator is obviously very important in case of Kubernetes. It adds labels and annotations to the log streams by interacting with the Kubernetes API. To get efficient results, you will need to precise the namespace and the pod name. You can customize the name of the fields containing your namespace or pod with the namespace field, the pod name field. So here is an example. We used just the type Kubernetes metadata decorator. We didn't specify the namespace and the pod name because in our logs we have the default name, which is namespace, and the default pod name, which is the pod underscore name. As a result of that, Kubernetes will add all the labels that are attached to that specific pod in that specific namespace. Add will add new fields or resource or labels in our log stream. Copy a value from a record to a resource label, or a label to a record. Let's have a look at the output operator. We have stdout, so we will send the modified log stream to stdout of Stanza. File, to write directly in the file. We can push it to Elasticsearch. We can send it over to Google Cloud Logging. Forward, so forward will be there to send a log stream to another Stanza agent. And last, the neural link operator. Out of those operators, Stanza allows us to create our own plugins. And I will almost rename plugins into a log stream pipeline template. In Stanza, a plugin is a template that has a set of operators, which means you can create a separate YAML file for each of your templates. This template will be loaded in Stanza by either adding the file into the plugins directory, or you can use a folder of your choice by using an argument when you launch Stanza -plugins directory. There is a long list of plugins available in this URL in the repo of Stanza. So make sure to have a look at the existing plugins and take advantage of this. For example, if you want to parse Nginx extended logs, here is the format of the logs generated by Nginx. We can then imagine the pipeline that will extract our Nginx information. So if you create that template, we need to precise a version, a title, a description of this plugin, the minimal version supported by Stanza, which platform is this plugin compatible, so Linux, Windows, macOS, Kubernetes, in fact the compatible deployments of Stanza. And then we precise the various parameters of that plugin. So here we want to have a path, so the path of the Nginx file. We can precise a default value, so the default path of our access logs of Nginx. And last, we start our pipeline. So the pipeline, we want to use an input plugin to read from the files, the file input. And here you can see that you can reference to the variables that we had, so path. As you can see, we use the regex parser to extract the various fields, part of our records. And then we use a timestamp extractor to be able to extract the time from the log streams. And we precise the layout, how we want to present the time in our logs. We also use the severity parser to parse from the status, the HTTP status. And we use a mapping to be able to match the HTTP status code to a log level of our logs. Once the plugin has been loaded in Stanza, you can use the plugins in one of your pipelines. Here is an example of a pipeline. So you can see here the type is Nginx, and we have a parameter called path, and we precise the path to our logs. So at the end, what happens is Stanza will first look in the pre-built operators available. So in our case, he is not able to find the Nginx operators, so he will check in the plugins directory and take the file corresponding to our own plugins and generate on the fly a new operator. In the case of deploying plugins in Kubernetes, it could be quite challenging. But the good news is Stanza provides also utility helping us to package our plugins into a config map. So here is the URL to that utility. As a result, plugins could be added in a config map. So we'll have one config map for your pipeline and one config map for your plugins. In this tutorial, we will collect Kubernetes logs and push the modified log stream to Dynatrace. For these tutorials, we have several requirements. Of course, a Kubernetes cluster. We will deploy the Nginx ingress controller to help us to route the traffic to the right service. We will, of course, need a demo app. In our case, like usual, we will use the online boutique, the Hipster Shop. Because we push the logs to Dynatrace, we will need a Dynatrace tenant, and we will have to generate an API token that will allow us to ingest the logs. To ingest logs, we will deploy a local Dynatrace active gate that will be there to receive the various log streams and forward it back to the Dynatrace tenant. For this tutorial, I have created the experimental Dynatrace output operator that will help us to transform the log streams to the Dynatrace format and interact with the log ingest API. We will create a simple pipeline based on a pre-designed plugin, the Kubernetes one, that will help us to collect the logs from the various containers and add the Kubernetes metadata with the help of the Kubernetes metadata decorator. And then we will use the fresh new Dynatrace output operator to push the new logs to Dynatrace.
Like every tutorials that we have at Easy Observable, there is always a GitHub repository related to this episode. Today, we're looking at the Stanza repo that goes through the various steps. So very important. I'm not going to deploy everything because at the end is no bigger value for you to watch someone deploying everything. But all the steps to deploy this demo is available in this GitHub repo. So please follow on this. So starting, of course, you need a cluster like mentioned. Deploy the ingress, Prometheus. Prometheus will be utilized with K6 because K6 is going to push the metrics there. Even if we're not going to utilize the K6 metrics, it's just to make the test run, we need Prometheus for that. K6 utilize a feature of Prometheus, which needs to be enabled. So you will have to modify the Prometheus object. So keep in mind to do so to enable the remote writer receiver. So that's the important stuff. Once you have done this, two things which are important. First, like mentioned, we will need a Dynatrace tenant. So make sure to go, if you don't have any Dynatrace tenant, make sure to go to dynatrace.com and click on free trial to start a fresh new trial. You will get a fresh new cluster. And once you get the cluster, two things that you need for this demonstration, because we will deploy an active gate. This active gate will register automatically to your Dynatrace tenant. Just to remind, the purpose of the active gate is basically it's like a bridge that will allow you to interact, especially in our case, with our log ingest API. So to be able to deploy the active gate, there are a few things. We need a pass token and a SAS token in general, but we also need the token that will have the rights for us to be able to ingest the logs. So if you create a new token here, let's say Stanza demo, and then here there is a template here. So I'm gonna first click on. I'm gonna search here because I'm gonna combine several rights. So pass token here. So this is the one I'm looking for. So I'm going to click on those two ones. The other template that I need is I need the logs as well. So I need to ingest logs. So those are the two main rights that we'll need to do that. So make sure to do this because it will be required later on the steps. So that would be the first things. Other things in your Dynatrace tenant that you will get, make sure to, in the URL, there are a few information that will be required to be shared with this deployment script. So first you need to extract the environment URL. So it's everything related to id.live.dynatrace.com in your case. The first piece here is the idea. So you need to keep this and save it because you will need it when you deploy the active gate. So your environment ID, the URL, and of course the token. So if you look at my environment, we have first, if you look at the default namespace, the path that I will have all the Prometheus stack. So the Prometheus stack comes with the node exporter, the kubeset metrics, and so on. I have the ingress running as well, and Grafana. So Grafana, I'm not going to use it today. It's not the purpose of today's episode. And as you can see here, I have Stanza already deployed as a daemon set. In my case, I have a cluster with 4 nodes. That's why I have those 4 pods of Stanza running. Out of these ones, there's another two other namespace that you check. There is the Dynatrace, get pods from Dynatrace, so you will see the ActiveGate. So because you will have to deploy all the things related to ActiveGate in the Dynatrace namespace. So here we can see obviously that the ActiveGate is there, so it will be there to receive any API calls potential from the experimental Dynatrace output plugin of Stanza. So that's mainly the main requirements. Out of that, of course, I have the various pods running for the Hipster Shop. So if you check the Hipster Shop namespace, I have all the pods running. I also have deployed K6 here. K6 is there to generate traffic and produce indirectly logs from the various components of our cluster. So of course the Hipster Shop and ingress controller. So if you do kubectl get pods from the namespace K6, you will see that there is a load generator running. Let's have a look at the pipeline that will be utilized. So I have defined 2 pipelines, and here I'm going to show you the second one. I will feel free to look at the first one as well. But the first one, let me bring the plugins that I have used for this pipeline. So like mentioned in the episode, in the GitHub repo of ObserverQ, there is a project called Stanza Plugins. And in the Stanza plugins, there are all the plugins that has been predefined. The one we are interested today to be utilized to use because it's Kubernetes, we're going to use the Kubernetes _container plugin. And this Kubernetes plugin utilize, of course, because it's a plugin, you need to define the parameters, the version, and so on. So the cluster name, the pod name, the container name, and so on. So here, you can see that the pipeline starts here with a file input. So it's going to collect logs from from our cluster, and it's extracting also indirectly the container name, the pod name. So we don't have those as a parameters. It will be managed automatically. Then each routes based on the values. There is a regex parser to get to the time, the stream. So you can see that most of the stuff has been done. So it's wonderful. We don't have to worry about it. And as expected, it will also add the Kubernetes decorator to get all the details attached to Kubernetes. So what do we get out of this? So first, let's have a look before we look at what we get out of this pipeline. I want to share from the repo the current pipeline that is being deployed. So there are 2 pipelines in this repo. Let me bring it. The first one is the default one. So if you look at the default I have just deployed, is just to help you to see the value of what's going to be generated out of this pipeline without Dynatrace. So there's here in the first pipeline that is currently being used, is going just to use the Kubernetes container pipeline plugin, in fact, and just throw the results in std. The second pipeline that I'm using, this is the one I've deployed, is the Stanza Dynatrace. So this one needs to have some few variables being populated. So the cluster ID, the API token, here is the default URL to our ActiveGate, the Stanza ActiveGate, and we have an environment ID here related to our environment. So those are the things that is required. And as you can see, the difference between the first pipeline and the second one is just that first we apply a rate. So we will basically push 500 log streams by 500 log streams. And then we push it to this experimental plugin which is the Dynatrace output. Dynatrace output, what it does is just basically taking the log stream, restructuring the log streams to match the Dynatrace log ingest API format, and basically interact with the Dynatrace API. Just to show you as well, in this particular deployment of Stanza, I'm not using the official version of Stanza, obviously. I'm using the modified version of Stanza because I have included in that Stanza version the Dynatrace experimental plugin as well. So if you want to use the official one, make sure to grab the official image of Stanza, which is available in the ObserveIQ repo. Okay, so let's have a look at the pods running. All right, so we have the 4 of them running, and let's grab one of them. Let's say Stanza, this one. And let's have a look at the logs produced by this pod. Well, so let's pause it. As you can see here, there are obviously several stuff. So you can see that that's a log stream. So you can see that we have an object format with timestamp, severity, the text, and then because it's produced with the plugin, you can see that there is a label object, and the label object has all the labels related to that log stream entity related to that pod that we're looking at. And then we have the resource, and the resource, you can see it's more on which cluster, which container, which deployment. So there's a lot of very useful information as well there as well. And last is the record. So the record, you can see, because it's here in our case, it's been produced from a log. You can see that there is a lot of different details, various attributes, so end batch, instant, the level, and so on. And there is a message. So here the message is the actual content of the log produced from the container level. So if you go to logs here, I can see several logs coming in here. So let's drag this one, for example, thread ID. So there's a couple of things arriving this morning. And you can see here, there are several things. This is a log stream that has been pushed directly with this Dynatrace output plugin. And which is interesting is that you can see that lots of new labels has been added, attributes. So we have the stream std out, the plugin ID. You can see that this plugin has been structured by the container Kubernetes container plugin, and this is obviously a Stanza reference. And there is a lot of IDs, so the namespace, the container, the pod, the app. So basically all the annotations, all the labels that were in our workload has been pushed. And due to this information, Dynatrace is able to directly index that log to the right entity, the right screens, the right everything. So it's just wonderful. So let's have a look at maybe let's check the pod. So it takes, for example, this one, for example. So I don't know if it's going to be producing any relevant logs. All right. So here we have a lot of things. So you can see here, this is the logs that is been transformed and sent to. So it's an array of logs. So you can see that we have a big payload. So let me find the ending of. So here we have an entire event that has been sent to Dynatrace. That's basically one entry of the logs. You can see that we have content, and we have the content of the logs that has been pre-generated by the output plugin of Dynatrace. And then outside of that, once the content has been defined, we attach the various properties or labels of that log stream. So here we have the cluster ID, the metadata name, and so on. All the annotations of that workload, the service, the namespace, and everything. So that makes it faster and easier to attach the logs to your observability backend.
That's it for today's episode related to Stanza. As you can see, Stanza provide a lot of features that are pretty interesting. First, the way of designing the pipeline that is pretty well structured in a YAML format, similar to what we used to, especially if you're working in a Kubernetes environment. What I especially like with Stanza is the notion of plugins. So plugin is not like the other log agents, an option, an operation, but it's a template. I like the fact that we have the options to reuse predefined pipelines in several projects. So we can share, we can reuse the work in various projects. Again, the Dynatrace output operator is in an experimental version, so don't expect any specific support, but at least it showcased that with Stanza, it's possible to also ingest logs in various backend, observability backend of your choice, and especially in our case, Dynatrace. If you enjoyed today's content, don't forget to like and subscribe to the channel. And thanks for watching, and see you soon for another episode. Bye.